Hello and welcome to another edition of our weekly webinar. My name is Dan Freeman and I'm the Senior Application Specialist here at Foster & Freeman. Today is a little different, and instead of introducing a new product or talking about a range of products, we'll instead be focusing on a particular feature that we discussed in a previous webinar. So in our previous VSC webinar, we introduced the VSC8000 HS, our latest flagship model in the VSC range. And in that webinar, we spoke briefly about a relatively new feature, 3D imaging. During that particular webinar, we received many questions relating to 3D imaging and its possible applications and limitations. So we hope to address a lot of those questions today, and we'll show you many examples in a lot more detail. As always, guests are muted during this first part, but please feel free to ask questions at any time in the comments section on the right-hand side. And at the live question and answer section at the end, we will endeavour to answer as many questions as we can. If you are not able to join us for this particular webinar, then please feel free to visit our website where you can download and watch the webinar on demand. For more than 40 years, Foster & Freeman has been manufacturing class-leading products for the examination of question documents. Our ESDA system, the very first Foster & Freeman product, is still manufactured today and remains an industry standard technique for visualizing indented writing, despite barely having changed in design or functionality in all of the years that it has been in use. Today, the company is perhaps best known for our VSC range, the latest of which, the VSC8000 HS, we will be using today. Unlike the ESDA, our VSC instruments are regularly updated with new hardware and software functionality in order to keep the examiner up to date with new secure printing technologies, and also in an effort to stay one step ahead of the counterfeiters and fraudsters who themselves are using ever more increasingly advanced techniques to counterfeit and forge documents. However, the day-to-day work of document examiners worldwide remains rooted in the examination of pen and ink strokes, particularly signatures, and the verification of traditional security features such as ink stamps. This is why we have produced the VSC8000 HS that is a complete solution for the examination of all document types, suitable for the inspection of both new and old documents and security features alike. In over 11 years of training at Foster & Freeman, within document examinations, one of the most frequent questions I've often been asked is relating to intersecting lines, or the sequencing of certain features on a document, such as handwriting and stamps. This has always been an incredibly difficult question to answer, but now we have more tools than ever to help determine the answer to the age-old question of which came first. It is worth noting, however, like in all areas of forensic examinations, these results are the results of a scientific process, and that these tools are there to provide the examiner with as much information as possible so that they may then go on to draw their own expert opinions beyond any reasonable doubt. There may often be times where we simply cannot determine, for example, the order of intersecting lines using tools discussed today, and there may be many factors that may be contribution to this, and we will talk about those during the webinar today. So the first technique that we will be concentrating on is 3D imaging. This was first introduced on our VSC8000. So it's worth noting again that everything detailed here today is also relevant to the VSC8000, but we have made some improvements to the hardware and software on the VSC8000 HS. Essentially, the 3D imaging works by capturing a series of images taken with LED lights at different angles. The different angles of light create shadows and highlights on the surface of the document being imaged. These images are then combined, and using advanced mathematical image processing functions, we are then able to generate a 3D image of the surface. In this example, we have two signatures. On the left, the genuine signature, and on the right, the person is disputing the origin of this signature. In this example, we will examine the genuine signature, highlighting this point of intersection on the first few letters. To do this, we will click on Tools and then 3D Imaging. It is usually advised to use a higher magnification to get the most clear results possible. As instructed, we will check the focus and then click OK. We will give this a name. The VSC will then take a series of images under different lighting angles, and then the 3D imaging software will automatically open. Here we need to select the desired area to process. In the majority of cases it won't be necessary to select the entire image, so to increase the speed of the final results we will just select the small point here and then click Generate. Once the results have completed, the screen will look like this. In the middle you have your 3D image. We can use the mouse wheel to zoom in, and then we can click and drag to spin the image into the orientation that we desire. In this case it should be quite evident that the first line, the much fainter line, was the first line which has been intersected by this line coming in across the diagonal angle. On the right hand side we have a variety of different tools to try and change the viewing options and to try and accentuate any differences on the point of intersection. One tool that is very useful is we can exaggerate the heights and depths of the surface. We can also invert the image as well, and here this can be quite useful to again show how this line here has intersected the first line running vertically. We can also change the image color, so we can revert it back to the original image, or we can have this as a single grayscale image, or as the image originally started, using these bands, the colors of which highlight the different levels of depth. So the blue are the lowest points on the image, up to red, which are the highest points. You can change and customize these in the options here as well. Instead of moving and rotating the image, we can also simulate moving the light source as well. So of course we are not physically moving any light source, but we can simulate this different orientations using the controls here. We will repeat this process for the disputed signature, again following the same steps as before. Here we have the results for the disputed signature. Again, we can zoom in and have a look at the point of intersection, and here we can quite easily see that there is a point where the groove of this line here has been intersected by this line. Again, we can adjust some of the controls to try and further highlight this. And because we've already captured our previous result, what we can also do is open up our previous project. And then using the various view comparison tools, we can then compare these results side by side. So here we have on the right hand side the original signature, where we believe this is the line that has intersected the first line. And here our disputed signature, we can see that it is this line here that we believe is the second line intersecting this one here. So here the results are indicating that the orders are different, and therefore the signatures have been written in a different way. Here we have another example of a stamp and handwriting on a passport page. So if we start in color, we can see where the handwriting and the stamp is present on the document. But once we switch to the colors, once again we can see that we are able to detect the indentations caused by the handwriting, but the stamp there is no visible trace, again due to the lack of pressure applied to the paper. So once again this is just showing the possible limitations of the 3D imaging caused by the different variations in pressure and tool type used to mark the paper. Here we have enlarged a portion of the serial number at the bottom of the check, and we can see that there is an area that looks interesting. We can use the side lights, and this gives us a nice result where we can see where one of the numbers has been inserted on top of the previous number. We can also use 3D imaging to show this as well. So once again we will go through the 3D imaging process and have a look at the results there. So here we can have a look at the 3D image, once again zooming into the area of interest, and we can clearly see the highlighted area in red indicating the higher level of paper that has been deposited on the surface. It's worth noting that the 3D imaging can be very sensitive, and we are able to actually reveal some of the laser printing deposition on the surface of the paper as well. So here we are examining the reverse side of the British driving licence, where we want to look at the embossed engraving on the surface of the laminate. This is a tactile feature quite similar to intaglio printing, and quite often the best light source for showing this is the side lighting. So here we can see that quite clearly, but we're also seeing obviously the background of the document as well. One other light source that does work very well for this feature is the coaxial light source. So we would normally use this for retroreflective laminates in passports and some driving licenses and ID cards, but here this works really well to show the embossing of the surface. However, if we wish to examine this in more detail, once again we can use the 3D imaging to further process this. So this is the result of the 3D imaging, and here we can clearly see some of the engraving on the surface of the laminate, as well as the area of printing. The area of printing is of note because this is not intaglio printing, so this is printing that has a three-dimensional effect, but is actually embedded within the laminate itself. So you cannot feel this, and it's something that you cannot easily reveal using side lighting. So again, 3D imaging has really clearly highlighted this printing, and we can analyze this in a lot more detail as well. In this example, we've used 3D imaging to look at the surface of a coin. Here we can clearly see the surface topography of the coin itself and any damage and scratches and marks that we might find on the surface itself as well. So as we have seen in the previous examples, the increased resolution of the new VSC8000 HS enables us to capture incredibly detailed images of a variety of surfaces and document types. This has also been made possible by the advances in computer processing power, and as a result, some of the older VSCs may require a computer upgrade if they want to fully utilize the 3D imaging capabilities. If you're in any doubt, please contact Foster & Freeman or your local distributor for more details. As well as 3D imaging, the VSC's illumination and optics technology allow us to determine the sequence of lines that were added to a document using another purely optical technique. In cases where printed lines or text appear over or under handwritten text, it can nearly be impossible to determine which line came first. A kind of optical illusion often occurs whereby the darker coloured ink nearly always appears on top. Using the powerful coaxial light source within the VSC8000 HS, we can see through this illusion to determine the sequence of lines. Under coaxial illumination, a sort of bronzing effect is observed, where the handwritten ink is placed over the top of the toner. This cannot be seen by the naked eye and is only possible to be viewed using these coaxial illuminations. This technique is only applicable where ink and toner are in question. And this technique is available on all VSC instruments and is made possible by the inclusion of powerful coaxial LEDs. So here we have magnified an area of interest, and we were trying to determine which came first, the handwriting or the printing. So here we are illuminating with our normal floodlights, and it's very difficult, if not impossible, to determine the order. However, something that we discovered a while ago is that if we use the coaxial light source, the handwriting exhibits this particular effect. We refer to it as bronzing. So the handwriting is essentially reflecting this coaxial light and giving this gold bronze appearance on the surface. This is a clear indication that the handwriting is on top of the printing. So here we are magnifying the same area on the other document, and once again it is inconclusive using the floodlights to determine the order of the sequence. Again, if we activate the coaxial light source, on this sample we can see the absence of this bronzing effect. So the areas of intersection between the handwriting and the printing, we are not able to see this reflection caused by the coaxial lighting. In this example, this would indicate that the printing has come second. So the writing was first and the printing has come second, which is subduing or masking this bronzing effect that we saw on the original document. So here in this side-by-side comparison, you can clearly see the difference in the interaction of the handwriting and the printing, both where the writing was written second and here where it was first. So this is a common technique that can be employed where we are examining the difference between handwriting and printing. But once again, there are limitations to this, and it is something that we are exploring as we do see variations in the different type of pen or handwriting and also the different type of printing techniques as well. At the heart of the VSC8000 HS is a redesigned lamp tray that includes predominantly LED illumination. Throughout the evolution of the VSC family of products, there has been a gradual shift away from the traditional incandescent lamps to LED light sources. LEDs have many advantages over traditional light bulbs, and whilst many know about their incredible durability and lifespan, not so many are aware of other advantages such as their efficiency, and today's LEDs are over twice as efficient as LEDs of around 5 years ago. The colour accuracy, in terms of the dye substrates are manufactured, have resulted in over 20% superior wavelength uniformity and more power. Whereas 10 years ago, traditional LEDs were outputting around 15 lumens per watt. Today, that level is around 50 or 60 and can be achieved on a standard 20 milliamp LED. Another commonly examined feature of question documents is the humble ink stamp. Widely used within the immigration setting and the sign of a well-travelled document, these are often used as a stamp of verification or authentication. It's easy to understand why a fraudster may wish to counterfeit or tamper with such a feature. Beyond passports and secure documents, ink stamps are also a feature of philately, stamps and postage marks. Originally hand-stamped but now most commonly part of a mechanized process, better visualization of these postage marks can be of great interest to philatelists and collectors worldwide. Foster & Freeman has worked closely with the Royal Philatelic Society, seeking new and improved methods of examining and verifying stamps and postage marks. Most commonly, infrared imaging is used to drop out inks to enable enhanced visualization of the markings and print details. In cases where stamps may be worth millions of dollars, VSCs are employed at the highest level of forensic examination. Further development of these techniques has recently led us to discover a new method of stamp examination using the system's isolate color functionality. By isolating colors present within stamps, we can now remove the appearance of intersecting lines or the background to enable a better, unobstructed examination of the stamp in question. Here are some further examples. On the VSC8000 and VSC8000 HS, in Tools, there is a section called Isolate Color. In this example, because the stamp is red, we can use the Isolate Red color. If we click on this, the software will try to remove as much of the background or as much of the image that is not red as possible, which in this case is leaving us with the majority of the stamp. In some cases, we can further increase the contrast and process this further by using the included image processing tools. In this case, we could experiment with the RGB channels to try and remove more of the background and exaggerate the stamp even further. So why choose the VSC8000 HS? So while no question document examination technique is capable of giving definitive yes or no answers, what a VSC system offers is the most rigorous and possible examinations of a document. Under many examination techniques, conditions enable us to reveal invisible details and expose alterations and tampering. The VSC8000 HS is by far the most advanced VSC to date and offers unrivaled examination functionality. With our highest image resolution to date, along with improved optics, as well as introduced color calibration for consistent image quality and color accuracy, even between devices as well. And with a variety of advanced imaging modes, such as our hyperspectral imaging, 3D imaging, which we've discussed today in detail, and super resolution image functionality as well. And not also forgetting the integrated spectrometer, a standard item in the VSC8000 HS. This is an advanced tool for taking color measurements and also seeing how inks and other features react over a visual and infrared wavelengths. And the motorized XY stage, which is an invaluable tool for examining documents under high magnification. So for more information on the VSC8000 HS or any other VSC in our range, please visit our website, and I encourage you to download our previous webinar where we discuss and compare these various VSC ranges. If you have any other further questions, please feel free to contact us at sales@fosterfreeman.com. If you have any questions on today's webinar, please type them into the chat box now, and we will switch over to our live question and answer session where we will answer as many as we can.